This is question 4. This is your dead straightforward, easy as they get graph question. They give you the equation, you stick the x values in, try not to forget to put the x value in a bracket because that will be wrong otherwise. So when you're busy working this one out, if you don't put that inside a bracket, it's going to be wrong when you square it, right? You plot your points, hopefully you do a nice job, right? Then it says, use your graph to solve the equation fx is equal to 1. You know that fx means y, so that's y is equal to 1. So you draw the line y is equal to 1, or you go from y is equal to 1, and you solve your equation. So that's that point over there. You are supposed to show this very, very clearly on your graph. If they don't see the lines you've drawn in, consider yourself to have lost those marks. Then D, it says there's one negative integer value for which fx equals k. So they're saying your fx is x minus 1 over 2x squared, and then they're saying y equals k, so a completely different equation, and they're saying where are these two equal, and there'll only be one solution. Now, when they do this, and they say this k is always a constant, so it's going to be 3 or 4 or 2 or whatever, and they say they want one negative integer value for k, right? So they're saying, where will we get, when we look at that line there, when we look at the original curve, and we look at where our original curve crosses another line that is a y line, right? So if it was y is equal to negative 4, there would be two solutions, there and there. If it was y is equal to negative 3, there'd be two solutions. Actually, there'd be 3 by the looks of things. If there's y is equal to negative 2, there'd be 3 solutions. There are 3 places they cross. If it's y is equal to negative 1, there's 1 place they cross. If it's y is equal to 0, there's 1 place they cross. If it's y is equal to 1, there's 1 place they cross. If it's y is equal to 2, there's 1 place they cross. And if it's y is equal to 3, there's no solutions, right? They've said to you one solution, and it has to be a negative integer. So that is when it's negative 1. No doubt about that. The next question says that you've got to turn 2x minus 1 over 2x squared minus 2 into the original equation. So these are exactly the ones that you practiced when you did your homework. This is 100% the most typical question, and they've given you nice, easy numbers to deal with. So I need to turn that into that. So what am I going to do? I'm going to add 2 to both sides, and I'm going to subtract x from both sides. Now I have the line y is equal to 2 minus x. I'm going to draw it, which is there, and I'm going to check that where it crosses. Where it crosses, that's my answer, and I write it down nice and clearly, so that you can see everything is shown on the graph. Be careful with your scaling. That's 1 unit there, that's 1 unit there. My original y line was wrong because I decided to see half a block, well, 1 block as being 1 unit when it was 2. So be careful with your scaling. Okay, next question. This is very, very, very basic probability. 2 apples are chosen out of the 160 apples without replacement. So what is the probability they both have a mass of more than 120? There are 40 apples with a mass of more than 120 out of 160. So your probability will have a mass of more than 120 is 60 out of 160. The next one, 39 out of 159, because you've used an apple, so there's only 39 left, and the total is out of 159. That is the answer as a simplified fraction. They have given in the memo the unsimplified fraction. It says OE next to it, which means or equivalent. So they'll accept that. They'll obviously accept this. This is more correct. And they will accept the decimal version correctly rounded to 3 significant figures. The next one says 1 has got a mass of more than 120, 1 of the mass of 80 grams or less. More than 120, that there are 40 of them out of 160. And then the next time I take an apple, there'll be 159 because we've already taken 1. And there are 50 that are less than 80. So 50 out of that. And then you've got to remember it can go the other way around as well. So there are 2 ways this event could happen. You could take the heavy apple first and then the light apple, or the light apple first and then the heavy apple. And that's why you have 2. So that's probably the hard thing about that one. This one is question, I'm just trying to remember which question this is. I didn't write it down. Okay. Question 7. Very basic. You work out the area of the one, you work out the area of the other one. In terms of y, you put them, make them equal to each other, and you solve. And factorizing for the other one's super easy, so I'm not sure where the problem was for this one. For this one's a little bit harder. This one is a reasonable question. The angle here, due to co-interior angles, is 180 degrees minus 2m. The angle over there, due to co-interior angles, is 180 degrees minus m. So we've got both of those two angles in terms of m. And you are supposed to recognize that this is the exterior, the angle at the center, and this is its matching angle at the circumference, which is very hard for people to see. Remember, if we looked at this one here, its angle at the circumference would be coming off this chord, would be like that. Notice how they face the same direction. So I'm going to work out the angle at the center and say 360 minus 180 minus m, because obviously the angle around a point is 360. And then that's equal to twice the angle at the circumference, and solve. Okay, but you've got to get used to that. That is one of the hardest geometry rules to see. And you've got angle, the reflex angle at the center, the pink one, is twice the angle at the circumference. And you've got to start getting used to seeing that. Look at the way that both of those two arcs face. Question 9. You need to know that this is always equal to x. So you need to add it to your notes, right? I've put the proof over here. So it would be a good idea for you to add a proof to your notes. And the proof is that if we take an arbitrary equation, I made up one, px is 2x minus 1, then the inverse is going to be x plus 1 over 2. You can check, but that is the inverse. If I then take the inverse and I put it into my px, which is what I've done here, I end up with an x. If I go the other way around and I put px into the inverse, I end up with x. So please just know that. They often give it for difficult ones that you can't work out easily. 9g, if you were wondering about which statement is true, you work out the inverse for each one and see if they're the same. The inverse is the same for gx. So gx is a hyperbola, and if you go and you solve for the equation and you do the inverse, they're the same. So that's the one that's the same. And then h, there is no particular method for you to work with. You just have to look at the original functions you were given and fiddle around and work out which combination is going to give you the answer. For question 10, this is a bit of a concern that you would be asking for it, because all of these are straightforward, exactly typical sequence questions. So the first one has got a constant difference of minus 7. So you're going to say minus 7 times n, and that would give me minus 7. If I want to get to 15, I'm going to have to add 22. Or you could use this formula here, or you could use this formula here, right? In either case, you're going to get minus 7n plus 22. For B, fair enough, maybe this threw you off, but you need to look at the two as separate sequences. So if you can see an obvious sequence in the numerator and an obvious separate sequence in the denominator, do them separately, right? And so that's what I've done. For C, this is an absolutely dead straightforward quadratic equation. I wasted a lot of time busy doing it the long way. Working at A is the second difference divided by 2, knowing that C is the zero term, and that B, that term 1 is equal to A plus B plus C. That's very important. You should know that theory, but it wasn't necessary. Surely 2 is 1 squared plus 1, and 5 is 2 squared plus 1. That one's fairly obvious to just see. The last one is your typical geometric sequence, 6 divided by 2, 18 divided by 6. So the common ratio is 3, and the first term is 2. You fill in the formula. You need to go and study. You're wasting your time if you're doing these questions and you're not studying.